Okay, the chart here or the table applies to two different questions. It gives the acceleration constant due to gravity for each of the planets, and it's in meters per second squared, and they're telling you that your weight is your mass in kilograms times your acceleration due to gravity, that gravitational constant, small g. And let's see what the questions they are then asking for. Many of you who take physics probably already know that the acceleration constant, or little g on Earth, is 9.81 meters per second squared. Now we see it for all the different planets. What is the weight in newtons of an object on Mercury with a mass of 90 kilograms? So your weight is simply your mass times your acceleration constant. So that's going to be 90 times the acceleration constant on Mercury. On Mercury, that's 3.6. So it's 90 times 3.6, which is roughly 3 times 90 is 270, plus another 54. It's going to be 324. The correct answer for 10 is D, 324. Note, none of the answers are even close. You can use estimation to get an exact answer, even on the calculator side of the exam. Number 11. An object on Earth has a weight of 150 newtons. We'll use the N for newtons. On which planet would the same object have an approximate weight of 170 newtons? Okay, so the way I would do it, I would just quickly estimate this is more than 10% greater. It's 13.33% greater than the weight given. So what acceleration constant is about 10 or 13.33% greater? Well, 10% of 9.8 is 0.98. So I'm going to be at least 10.8. I'm going to be a little above that. Looks like Saturn 11.1 is going to fit that answer. So it seems to me the answer is going to be Saturn. Now, you might point out Uranus is very close at 10.7. However, that's only 0.9 differential. 0.9 differential is still less than 10% of 9.8, and 20 is greater than 10% of 150. So the answer would be Saturn. So that's how I would do it, looking at it and using estimation abilities. What one might do formally or algebraically is set up a proportion equation. We could say 150 to 170, that is your weight on Earth, to the weight on some planet, right, equals the mass is going to be the same. That does not change. That's the amount of stuff in the object. But the accelerations due to gravity will be different. So on Earth, that acceleration constant is 9.8. On the unknown planet, it would be x. So then we could cross multiply and solve. So we do 150 times x, cross multiplying there. 170 times 9.8 there. And then we could divide by 150 on both sides and solve for x. And we would ultimately get 11.1, the same answer. And we realize it must be Saturn.